All right, we'll give people a second to get settled. But while people are getting settled, if I could encourage people to move up to the front of the room. The Internet Visualization Exhibition is about visualizations, so the better you can see, I think the more you'll enjoy what we have to present today. While people are getting settled, let me introduce myself. I'm Paul Barford. I'm a professor at the University of Wisconsin-Madison, and the Internet Visualization Exhibition is a session that I have organized in collaboration with my friend Lachman Salamatian, who is a PhD candidate at Columbia University. So as we get things started, I'll maybe draw your attention to the Internet Visualization IVE logo in the upper right. This is the obligatory ChatGPT generated logo. I'm not sure I'm satisfied with it. It maybe is not capturing the kinds of things that I want to convey, but we'll do better as we go forward. All right, so let's see here. Advance. All right, so let's, I wanted to start with some visualizations. As you all know, the old saying, a picture is worth 1,000 words. So let me just go through some visualizations that I think are relatively compelling to sort of set the stage for internet visualizations. And we'll start out with what's in the upper left. This is probably a visualization that some of you have seen. This is a very famous depiction of Napoleon's march to Moscow that was generated in the 1860s by a fellow named Menard. Has anybody seen this visualization before? It's often held up as one of the best visualizations in terms of conveying information. So as you start from the left, Napoleon has a big army as indicated by the wide brown bar. And as he gets closer and closer to Moscow, the army gets smaller and smaller. Also in the illustration, there's time and temperature that's depicted, as well as the geographic route. And then the black indicates the return with an ever-dwindling force. So when it comes to visualizations, this is something that's very often shown and held up as something that is a great depiction conveying lots of information. And then across the different scientific disciplines, you've got things like the famous double helix. If you just read the word double helix and you're not familiar with geometry, maybe it's not something that's intuitive, but of course the minute that you see a picture of it, it makes sense. Moving to the upper right, we have a wonderful depiction from National Geographic of the evolving universe over the eons, something that is sort of visually compelling and also illustrates how things have moved and morphed over the eons. Moving to the lower left, an illustration that I found personally very compelling. This is an illustration of the growth and diversification of languages over time. So we have these wonderful depictions across, again, all these disciplines. Moving to the middle of the slide, although you can't see it very well because it's so small, this is actually an illustration of the agricultural industry, in particular in the US, depicting the different stages from crops growing to delivery to stores and so forth. So lots of different pieces of information conveyed here in a pictorial representation that makes people pay attention to it. And then in the lower right, what we have is a depiction of a complex shape. This is actually a manifold depiction from our folks in the world of mathematics who draw some very, very interesting shapes over time. I didn't put the formulas up that describe this shape from a formulaic perspective, but I find visualizations like this very compelling. So with that as sort of a starting point, hopefully it captures your attention. Let me talk about what we're trying to do with this session today, which is really simple. It's to recognize and celebrate illustrations and visualizations that are cool and innovative and that are primarily focused on internet data. I don't want to limit it to internet data, although that is the primary focus, but want to emphasize that there are lots of opportunities to create depictions of internet systems, internet protocols, and so forth. And I hopefully am going to present some of those today in a way that inspires you to think about how we might expand the scope of illustrations that we use in our papers. So there was a lot of discussion yesterday in a couple of sessions that I went to about community. Hopefully this session is the starting point for fostering a culture and community that recognizes and appreciates visual thinking, and that brings together even a broader scope of people, including practitioners and even artists who are interested in compelling visual representations of data. And then finally, what I'm hoping for at the end of the session today and after the session is to spark conversations about how we might expand the inventory of visualizations that we use to depict data or systems that relate to the internet that ultimately lead to a deeper understanding and appreciation of the work that we're doing. So before I move on to more illustrations, I want to point out that we are not the community that's probably spent the most time thinking about this. There are people who spend their whole careers thinking about visualizations, and I'm sure that some of you out there have heard of Edward Tufte, maybe a few. Great, so a couple of hands raised, but even better that I don't see a lot of hands raised. So I really encourage you, if you're interested in visualizations and depictions of data, to take a look at his very famous book, The Visual Display of Quantitative Information. It's a book among only a very few that I actually keep on my desk, because it lays out a set of ideas about capturing data in ways that are compelling. Of course, he has Menard's visualization sort of front and center in that book. And there are sort of a number of, I think, relatively straightforward precepts that Tufte talks about that are keys to creating great representations of either data or systems. And they are as follows. Show the data clearly and honestly. And he talks about the idea of a data to ink ratio, where we want to represent as much data as possible with as small amount of ink as possible. He also makes the point that it's extremely important to provide context for visual representations that allow comparisons to be made. It's always hard to consider things individually, and much better if you have a means for creating some comparisons that enable you to reason about what you're seeing, and to provide the highest resolution possible. Don't oversimplify the data, don't obscure things. Provide high resolution so that people can fully understand what's being presented. And that's sort of what I captured in the last bullet. All right, so I'm going to move on to some internet-related visualizations and the evolution of these over the years that I think are compelling. Of course, this is my opinion. You've probably got your own opinions about things. But we'll start with the upper left, which is the first visualization that was captured in an RFC. So this is a visualization from RFC 001, the first one that was written by Steve Cocker in 1969. And what I would contend is it's not very compelling. So simply using the capabilities of a keyboard to create a representation of the software system, which is what RFC 001 is about, that was deployed on IMPs in the very early internet. So thankfully, we've moved on fairly significantly from there. We'll move to the upper center, and some of you probably recognize this illustration that was included in Van Jacobson's 1988 SIGCOMM paper on TCP. And this is actually the illustration that was included to demonstrate self-clocking of TCP in that paper. And what's interesting about this illustration is that it had a significant outcome with respect to sparking ideas in a totally unexpected way. So the idea of a packet moving from a network that has large bandwidth to small bandwidth to large bandwidth again was recognized as an opportunity to actually measure the bandwidth in the constricted link. And over a period of time, in the early 2000s, there was a bunch of work that was done on estimating bottleneck bandwidth. This was sort of pioneered by my old friend Konstantinos Stavroulis from Georgia Tech. And I think it's a great example of an illustration that maybe was meant to convey a relatively straightforward context, but then led to a whole bunch of studies on something else that was important. And at the end of the day, if we can have illustrations or visualizations that spark completely new ideas, then I think we've accomplished a great goal. If we move to the upper right, of course, there were many, many illustrations after the Van Jacobson paper in 1988 on TCP that illustrate the behavior of the congestion window. And this is one amongst many that you can find in those papers from the 1990s on all of the different variations of TCP. You can argue whether or not the data to ink ratio is appropriate here, but I think this was an illustration that I found that has a lot of information about that behavior and is useful for understanding, in this case, TCP Reno. As we move to the lower left, I just picked out a simple illustration of a protocol, right? So we've seen lots of these kinds of visualizations in papers over the years that convey a bunch of information, including the packets that are exchanged between hosts, the delays that are experienced between the packets, and ultimately the conclusion of connections. These are diagrams that I'm sure the professors in the class who teach introductory networking courses use all of the time in their classes, and they're quite effective at teaching students, at least, the basic ideas of exchanges of packets and protocols. The illustration in the lower center is one amongst many that was generated by my old friend Vern Paxson in his 2023 Internet Measurement Conference Distinguished Award. And it's an illustration of the growth of evolutions and connections, as is indicated, seen at LBL. Vern, as we all know, is a pioneer not only in internet measurement, but also in creating visualizations. And I urge you to take a look at his IMC 2023 presentation. It's probably 90% visualizations, and many of them are really compelling with respect to the changes in packet traffic in the internet over the years. Finally, in the lower right, we have an illustration that I wanted to include really to just highlight the fact that our friends at CADA, CADA.org, have recognized the importance of illustrations over the years. The particular illustration that I show in the lower right is a diagram of the autonomous systems topology. I always found this very interesting. I'm not sure that it conveys a tremendous amount of information, but I give credit for creating something compelling visually. All right, I'm going to move on here. So I'm going to take the next two slides and present some of my personal journey that led me to where I am today, standing in front of you talking about visualizations. Does anybody recognize the figure on the left side of this diagram? Anybody recognize it? A couple of people. I'm not seeing one person raising their hand who actually created the visualization. But this is actually, believe it or not, this is the illustration that got me interested, really interested in measuring computer networks. So it's a diagram that was included in, or a set of graphs that was included in Walter Willinger's self-similarity paper from the mid-1990s. And what it shows is the difference between self-similar traffic, if you aggregate over larger and larger time bins, versus Poisson traffic, which tends to flatten over time. And I just really couldn't quite wrap my head around this. I didn't really understand what was going on for a long time. So as the story, my personal story goes, I was fortunate to actually do my PhD at Boston University because Walter's PhD advisor, Murad Taku, was there. And Murad taught a class while I was there on self-similarity, amongst other things. And he had a very interesting way of lecturing, which was to basically splash equations across the blackboard. Anyway, long story short, I got an A in the class, still didn't understand anything about self-similarity mathematically. I took the class again, Still didn't really understand it, but I was kind of getting used to it by that time, so I think I have a little bit better understanding. But really, just going back to the illustration, which is sort of a compelling starting point for then looking at self-similar aspects that appear in nature, I was kind of captured and have thought about it ever since. Again, just sort of for self-promotion, an aspect of work that I've been very interested in for a long time was understanding internet connectivity. And in this series of illustrations, if we start out in the upper left, what you have is the illustration of connectivity in the original internet. So the first 4 nodes that made up, well, what was called the ARPANET at the time. And for a long time, people started to pay attention, really catalyzed by the work that Vern Paxson did. People got interested in this idea of connectivity. And it led to some really crazy visualizations. So we've got this sort of peacock diagram on the right. This was generated by some folks at Bell Labs, Bill Cheswick in particular, as a means for illustrating internet connectivity, only not, all right? This is a kind of artwork on the upper right, and it's actually generated from internet data, from traceroute data, but there are a lot of reasons why it's probably not an accurate depiction of connectivity. So I was studying this for a long time, and I would always be asked by people, they would say, you know, what are you working on? I would say something like topology measurement, and they would say, oh, show me a map of the internet. And for many years, I couldn't do it, right? I would show something like the traceroute-based peacock diagram and say, but it's not really the internet. So with some collaborators in about 10 years ago, we started to actually try to create a real map of the internet, and the result of that was captured in our SIGCOMM 2015 paper, which is a map of the long-haul infrastructure of the US. And I'm very proud of that, but the point is, there isn't a deep scientific contribution there. This was actually something that was just based on a lot of hard work and finding real maps of networks that were ground truth, and then putting the whole thing together. But I will say, despite the lack of what I think of as deep scientific contribution, this single map got more publicity than any other work that I've ever done. And what it does really is it highlights the fact that illustrations and visualizations are things that are compelling for people, right? When you can see something like this and it makes sense to you at some level, it's what you remember. And that's an important message that I think that I want to emphasize throughout the rest of the time here. And that map that we created in 2015 led to an even more detailed map that we captured in our paper that was published in IMC 2022. This is about IGDB. This is a database that you can get access to and that you can use, and that gives you details of physical infrastructure connectivity around the world. So the takeaway message here is maps are gold if you can come up with something new. All right, so getting back to the Internet Visualization Exhibition, we solicited contributions for this. We wanted people from the community to contribute new and innovative visualizations. We had 20 submissions. We carefully considered those 20 submissions, and we accepted all of them. So congratulations to the contributors. And what I'm going to do now is transition to a video that's going to take about 20 minutes of all of the contributions from the contributors. I hope you enjoy it, and on with the show. Oh, I'm sorry. There was some sound with some of these videos, but unfortunately we can't play the sound. So watch and enjoy, and hopefully the descriptions at the bottom will be sufficient to understand what you're seeing. think that would be great.
All right.
Absolutely. I'm feeling like at least we needed someone serenading this. I don't know. It's crazy though, isn't it?
If I say this one should be a TV channel, I should know my age.
Say what?
If I say this one should be a television channel.
Oh, yeah, yeah. No, I totally dig that. I watched the Burning Log channel.
Yeah, exactly.
Yeah, so this would be great. Oh, there was mine. It just went by.
Who wrote the captions? You or them?
The authors.
This is the first author to represent some limitations in the.
By the way, I'm sure that I'll say this later, but for everyone's information, this video in its entirety is going to be posted, so you'll have access to it, and we'll also post further descriptions of each one of the illustrations. So that'll all be available after the conference. Yeah, I wish we could see them a little bit better.
Cloudflare Radar is a tool that visualizes global internet traffic, attack, and technology trends. It is built for a broad audience, not just internet and data experts. Let's explore some of the application security insights available on Radar. The application layer security page provides insights into application layer attack volume and the top sources of such attacks. Users can view attack distribution through several filters, including the Cloudflare product that mitigated the attack, as well as multiple source and target views. The global view also provides a perspective on the top countries or regions that are sources and targets of application layer attacks, as well as the top network sources of such attacks. Here, we see that the autonomous systems associated with major cloud providers are leading sources of attack traffic. Please explore all of Radar's functionality at radar.cloudflare.com. If you have questions, you can reach us via email, as well as through social media on X, Mastodon, and Blue Sky.
Hi, we are the NetCell research group at UCI. In this demo, we show a visual representation of a trace route with submarine cable context using Nautilus, which maps IP links to submarine cables. To demonstrate this, I paste a sample trace route and click Submit. Hops appear as GPS icons on the world map, and nearby hops are clustered. For example, hops 2 and 3 in Taiwan. I click the Taiwan cluster to zoom in, then select a GPS icon to see hop details, like geolocation and AS. For the intercontinental link, Nautilus identifies the PLCN cable, as rendered on the map. Clicking the cable opens a panel with several relevant cable details, derived from Nautilus. This is how our tool transforms a raw trace route to a cross-layer visualization with submarine cable annotations, and an interactive version will soon be available for public use. Thank you.
The Internet Outage Detection and Analysis Project, also known as IOTA, is a research project and online platform that provides real-time measurements on global internet connectivity. IOTA provides various data visualizations, including maps, timeline views, as well as time series connectivity signals, and stacked horizon views. All of these various views are available at the country, region, and ASN or ISP level. We hope that these data visualizations are useful for our users who are monitoring connectivity in countries, regions, and networks that are important to them.
Okay, if you could just go back to my slides. That concludes the exhibition. Let me just, great, let me just, I think I have 2 or 3 more slides here. So we were very fortunate to be sponsored by ISOC to give an award for the best visualization. And after very careful consideration of all of the submissions, we decided to award the best visualization to the speed test heartbeat. Just really cool. Hopefully you all agree that it was compelling, so congratulations to Thomas Buck from Brighton Analytics. All right, well, we're at time, but I really just wanted to conclude, and people who want to go to lunch, please feel free to go, with a couple of thoughts. I'm just going to go through these quickly. If anybody wants to respond to them after I'm finished, please feel free to do so. Many of the submissions were sort of geographic or topologically oriented. One question is, do other data representations make just as good or even better visualizations that help to highlight internet data? A lot of what we saw were animations, but of course in papers, it's hard to include animations. So while certainly the animations are compelling, hopefully people will not forget that static visualizations are just as important. As you saw in the submissions, it sort of spans a range of static images, animations, and actual whole tool sets. We considered all of these, and I think that they're all important. The question is, as a community, what should we be focusing on, and what leads us to that sort of deeper understanding of data when we think about the full scope of topics that are addressed in SIGCOMM. One of the things that was sort of noticeably absent from the submissions were visualizations of systems and protocols. Of course, we said internet data, but I want to be clear that when we think about visualizations, we being Lockman and I and the other folks we talked to about the internet visualization session today, we think about it broadly, and we think that there are also opportunities for new and interesting visualizations of systems and protocols. And I just want to sort of leave with a final thought, which is that we are committed to keeping this internet visualization exhibition going for SIGCOMM'25 and beyond, again, to try to foster community and conversation about this issue that we think is very important. And we hope that others will look for this next year and contribute if you've got something interesting. So thanks to all of you for coming today. I hope you enjoyed the show. Thanks to Lockman for all of his hard work, and for the contributors for making their submissions. Thanks to Walter and Arpit for organizing the session. And with that, I'll conclude. Thank you.